Hi everybody. In today's lesson from section 13.7, we'll be taking a look at how to write an equation for a line given different pieces of information. Each time you are asked to write the equation of a line, I want you to think of it as like solving a puzzle where you are always going to be given two clues. Okay, for us, for writing the equation of a line, we are always going to write the equation of the line in slope-intercept form, which you should remember as y equals mx plus b. So that's the goal. Okay, in the first type, in our first example, it says find an equation for each line described below. In part A, it says our slope, which is m, is equal to -3/7, and our y-intercept, which is our b value, is equal to 2. So this is the easiest type of equation to write. We just have to take and plug in -3/7 in place of m in our slope formula, or in our slope-intercept form, and we have to take the +2 and plug it in for b. So therefore the equation for this line would be y equals -3/7 times x plus 2. And that's it. Slope-intercept form of that equation. Okay, in part B, the information is a little bit different. So remember what I said about thinking about solving a puzzle. This part is still pretty easy. It says our y-intercept is equal to 3. That is going to be your b value, but the problem is we don't have the slope. Okay, but what we do have are 2 points. Some people forget that the x-intercept and the y-intercept are actually points. They have an x value and a y value. If the x-intercept is -2, that's given to us, that means that the line is going to go through the point -2, 0 on the x-axis. If the y-intercept is +3, it means that the line would go through the point 0, 3 on the y-axis. Now that you have 2 points, you can find the slope. So we want to do slope is equal to the change in y. So I'm going to start with my 3. I'll do 3 minus 0. That's y2 minus y1 over x2, which is 0, minus x1, which is -2. And then clean that up a bit. 3 minus 0 gives you 3. 0 minus a -2 becomes +2, and there's our slope. Okay, write the equation now that you know the slope and the y-intercept. Y equals 3/2 times x plus 3. That's it. Okay, let's take a look at some more examples. Okay, recall from our discussion yesterday that point-slope form is y minus y1 equals m times the quantity x minus x1. Okay, when we use point-slope, we use it as a way to get our equation into slope-intercept form, kind of an intermediate step. You're going to be plugging a number in for y1 and for x1, so like the coordinates of a point, and we're also going to be plugging in a number for the slope. And then we're going to take that equation and solve it for y. Now remember that this equation is derived from the formula for slope, which is m equals y minus y1 divided by x minus x1. And all you would do is take and cross multiply, and you end up with point-slope form. Y minus y1 equals m times x minus x1. So if you forget point-slope form, just remember it comes from the slope formula. Okay, so our next puzzle says use the given information to find an equation for each line described. So we want to write the equation of a line through the point 1, 4, so that's giving us an x and a y, parallel to the line y equals 2x minus 3. So in a way, they're giving us another clue, because we know that if lines are parallel, they have the same slope. The slope of this line is 2, so the slope of our new line has to be 2. Okay, start off with point-slope form. Y minus y1 equals m times x minus x1. Okay, it'll be easier if you think about this point as being x1, y1. Okay, so plug in that information. In other words, we want to do y minus our y1 value, which is 4, equals m, our slope, which is 2, times x minus x1, which is 1. Okay, now sometimes in the textbook they're going to write their equation like this. But remember what I said. We're going to take our equation and write them in slope-intercept form. So distribute the 2 to the parentheses. We get 2x minus 2. And then take and add the 4 to both sides. I get positive 2. So y is equal to 2x plus 2. Now the great thing about writing linear equations is you can always check your work. So check your work by verifying that the slope is 2, because if these lines are parallel, they have to have the same slope. The slope is 2. And the other thing you can do is check your point, plug it in. If I put 1 in for x, I have 2 times 1 plus 2. That would give me 4 for y. So everything checks out. That's got to be the equation for the line that was described. Okay, and the next one, again we have our 2 clues. We have that point again, x1, y1, and this time we want to go perpendicular to y equals 2x minus 3, excuse me. Well, when lines are perpendicular, their slopes are negative reciprocals. So the negative reciprocal of 2 is negative 1/2. Okay, we have our clues. Let's plug them into point-slope form. So y minus y1 equals m times x minus x1. So we do y minus 4 equals negative 1/2 times x minus 1. Okay, remember we want to distribute on the right-hand side. So we're going to take negative 1/2 times x, and then we take negative 1/2 times negative 1, which makes it positive 1/2. Add that 4 to both sides, so here and here, and then we'll rewrite the final equation as y equals negative 1/2 x plus 4.5, or you could write 4.5. Either way is fine. And again, you could check it, verify that the slope is the negative reciprocal of our original slope, and check to see that if you plug in 1 for x, you end up with 4 for y. Alright, sometimes your 2 clues are just 2 points. So what's missing here is we don't have any information about the slope, but we do have 2 points, so we can find the slope. So I can do 1 minus 2 for the change in the y's, and I could divide it by 6 minus 3, the change in the x's. 1 minus 2 is negative 1, 6 minus 3 is 3. So our slope is negative 1/3, so hold on to that. Okay, so point-slope form, we want y minus y1 equals m times x minus x1. Alright, we have to choose a point to plug in there. We only need one of these 2 points, so I'm going to choose 3, 2. It doesn't matter if you choose 3, 2 or 6, 1, because they're both on this line, so they would both give us the right equation. So we want to do y minus the y value, which is 2, equals our slope. Sorry about that, I started to write the m again. So we want to plug in negative 1/3 for our slope times x minus 3. Okay, so keep this and distribute over here. Negative 1/3 times x is just that, negative 1/3 x. Negative 1/3 times negative 3, well, negative times a negative is a positive, and 1/3 of 3 is 1. Take and add 2 to both sides, add 2, and we get 3. So y is equal to negative 1/3 x plus 3. And that's our final answer. Again, what could you do to check it? Well, you can plug in each of your points and make sure that they work. In other words, you can do y equals negative 1/3 times 3 plus 3, and verify that it would be equal to positive 2. Negative 1/3 of 3 gives us negative 1 plus 3, that's positive 2 right there. Right? You could do the same with the other point, 6, 1, but I'll just tell you that it does work. Okay? Alright, just a couple more. Sometimes the simplest things seem the most complicated, and that's typically what happens when Students are asked to write the equation of a vertical line through a given point. And let's just sketch this out really quick. The point -2, +3. So I go left 2 and then up 3. So -2, 3. If we draw a vertical line through that point, it would look like that. Okay? Now, what's true about every single point on this line is that they have to have the same x-coordinate. You're always going to the left 2. For instance, this point would be -2, 0. Our point that we graphed up here was -2, 3. This point down here could be -2, -1. This could be -2, -2. You kind of get the picture. And what these points all have in common is that they all have an x value of -2. So basically, when you write the equation of a vertical line, you look for the x value and you just simply say x equals -2. This is a case where slope and slope-intercept and point-slope form are absolutely no help because the slope of a vertical line is undefined. Now, how would you put that into the formula? You can't. So we can't write y equals undefined times x plus b. Okay? We can't do it. Notice there's another problem. We don't have a y-intercept, so this part doesn't work either. Okay, so simply put, if you're given a point and you're asked to write the equation of the vertical line through that point, you just say x equals whatever the x-coordinate is. So in a similar manner, when we go to write the equation of a horizontal line through a given point, we just write y equals whatever the y value is. Okay, so it would be y equals 3 in this case. And here's a little bit more of an explanation for that. Okay, so if we have the point -2, +3, we're looking at this point again. And this time we have a horizontal line. Okay, well, we should know that the slope of any horizontal line is 0. Really, that says m equals 0. So imagine this. If I have y minus y1 equals 0 times x minus x1. Watch what happens when I plug in our point. We have y minus 3 equals 0 times x minus a -2. It doesn't really matter that that turns to +2 because 0 times anything is 0. So we have y minus 3 equals 0, which just simply would mean that y is equal to 3. There it is. So for horizontal lines, because every point on this line has a y-coordinate of +3, in a similar manner to the way in which we wrote the equation of a vertical line, for horizontal line, it'll just be y equals a number. And so it's whatever that number is in your coordinate pair. All right, good luck on homework number 7. As always, please make sure you email me with questions or speak up when we're together in class again tomorrow.